This is Jim Wall with the Gilson Columbus office. Thanks for joining me today in our brief video to show you how to configure the Siemens 5000 and 6000 mag meters. There's a few features differentiating the two, but the basic configuration is the same. More sophisticated setups can be done, but we're going to show you the basics to get you up and running, to give you a local rate and total, and get you a 4 to 20 milliamp output, and possibly a scaled pulse for a remote totalizer. You'll notice that on my mag meter, the Siemens mag meter that I have, the mag meter body is mounted integral with the transmitter, although a remote configuration is also available with cables separating the transmitter from the mag body. Either way, the transmitter is configured the same. Before we start with the configuration, one important point to note is that the sensor body has a chip that ships with it. That chip contains all the calibration factors unique to that particular body. It is important to note that when in a remote configuration, that chip has to be removed from the body and moved to where your transmitter is mounted. If you do not move that sensor, any kind of data entry that you're going to be doing is going to be in the equivalent of RAM memory. In the event of power loss, any configuration changes that you may have made will not be saved. And the mag meter will think it is defaulting to a 2-inch. So if you have a 6-inch flow meter, it's not going to read accurately at all. Now we're showing you the face of the transmitter. It's a backlit LCD display. Right now I'm showing you rate of flow in the selected engineering units, or US gallons per minute. The center line is my text line, and it's showing currently Totalizer 1. And the bottom line is giving you a value for that totalizer. You also note on the lower part of the display, I have 6 keys. The top row are navigational keys. The upper left-hand button allowing you to get in and out of the programming menu. Once you're in a specific level of programming, the center and the right key allow you to navigate back and forth on that level of the configuration menu. The second line allows you to enter data. So navigational keys and data entry keys. When I program the unit, I allow you to configure an operator menu. There's 2 modes to the mag meter: operator menu and configuration menu. In the operator menu, which is the default, I can scroll back and forth to see different values on the mag meter. The default screen for the operator menu allows you 5 different screens: rate of flow in Totalizer 1. If I push the center key to navigate to the right, rate of flow in Totalizer number 2. The default menu also has reset for Totalizer 1, reset for Totalizer number 2, and a screen that allows you to report any parameter that might be outside of the diagnostic parameters. Now let's scroll back around, guys, and we're going to come back to the main menu of resetting the totalizers, showing you the values for Totalizer number 1. Before I start in the configuration menu, you'll see shown on your screen at this point is a programming chart, and it's going to show you the basics of the first level of programming. Across the top of that chart, you're going to see the basic settings, operator menu, configuring the output. And by the way, with our magnetic flow meter, it ships with the 4 to 20 milliamp output in the off position. One of the reasons for this is that our transmitter does diagnostics. And so if you do not have anything wired to the 4 to 20 and it is turned on, it senses that it can't get to 4 milliamps. And therefore, you can't achieve 4 with an open circuit. In the upper right-hand corner, and we'll force it a little bit later here by turning on the analog output with nothing wired, I will get a diagnostic symbol saying, hey, there's an error here. and it is a square with a diagonal line that flashes. This is an indication that something's wrong with the magmeter. When I scroll over here to the 5th screen of the default, it will report no errors pending. If I had that sign in the upper right-hand corner, that block with a diagonal line flashing, it would report what error I had, whether it's an open on the 4 to 20, coil current, etc. Now, getting into the programming menu, I simply hold down the upper left-hand key and hold it for 3 seconds. You'll notice that the words password appear with 4 significant digits. In the lower right-hand corner, you'll see an icon that appears to be a padlock. Now remember, the bottom keys are for data entry. Hitting the keypad that looks like a padlock allows me to change the current status to open, meaning it's acceptable to make changes. You'll also notice that a cursor appeared under my most significant digit. Once that cursor is on the left-hand digit, the circular keys allow me to make a change to that particular digit. The default password is 1000. Had it been 1100, the second key, the middle key in the bottom row, allows me to progress to the next digit and change that, 1 digit at a time. Once I have the value that I want, my default 1000 password, the icon that looks like an open padlock changes to closed, meaning I've entered the data. It says, congratulations, you've made it to basic setup. Now, using my navigational keys, I'll scroll across and you'll see basic settings, output, external input, sensor characteristics, reset mode, service mode, operator menu, and product identity, and scrolls back around to your password so that you can change that password, that 1000, to whatever you would like. Starting at the top under basic settings, this designator in the upper right-hand corner or lower right-hand corner of your screen that was an icon appearing as a padlock, either opened or closed, changes. At this point in the programming, it's saying, hey, there's another level, or there's information down below to dig deeper. If I hit that padlock key that doubles as an enter key, I can get into basic settings. You'll see from the chart that now appears for basic settings that there's about 7 entries. The first one being, am I operating on 50 or 60 hertz? If you leave it at 50 hertz, you're not going to read accurate flows when you're applying 120 volts. If I choose to press the icon key for data entry, I can see I can toggle between 50 and 60 hertz. If I want to save it, I close the padlock. Once we have the frequency set to 60 hertz, I hit the right-hand key to navigate over to flow direction. There is an arrow indication on the magmeter, in this particular case going left to right. But if you happen to configure your magmeter and you're reading reverse flow, because a magmeter does differentiate forward and reverse flow, I can simply come into this menu item and reverse what is recognized as forward flow. So flow direction can be changed, negative or positive. We'll leave it as positive. Moving forward, Q max is the full scale flow rate for that particular size of meter. That can represent flows all the way up to 33 foot per second for any given magmeter size. Our transmitter will allow you, once it identifies that it's in a given size flow meter, will allow you to program equivalent values to represent 20 milliamps from 1.5 foot per 1.5 foot per second, all the way up to 33 foot per second. So Q max is the value that you want to represent 20 mils. In my particular example here, I have 100 US gallons per minute. If I want to change it, keep in mind that my bottom keys are data entry. So if I wanted to change that to 120, I simply scroll over to the digit that I want to affect, and I make that 120 GPM. I keep scrolling across, get all the digits in that I want, and keep going, because this allows me to affect my engineering units as well. So I could change that from US gallons per minute to 1,000 gallons per minute, million gallons per minute, so on and so forth. I'm going to scroll back around to US gallons per minute. If I didn't want US gallons per minute and I wanted to affect the time base, I can continue to scroll across. Gallons per minute, hour, day, second. We'll leave it at minutes for our example. Navigating across to the next entry is Totalizer. Now with the magmeter, both the 5000 and 6000, you have two totalizers. They can be scaled differently. They can be assigned for forward flow, reverse flow, or net flow. Net flow being, a good example would be a sand filter, so that you can use it as a cash register for the effluent of a water filter or a filtration plant for municipal service. And when it comes time to backwash, you want to take that value out of your cash register. So the net flow would do the subtraction for you automatically. Just as simple would be keeping Totalizer 1 for forward flow and Totalizer 2 for reverse, but that's your choice. So when I get into Totalizer, you're going to notice that in the lower right-hand corner, my arrow once again displaces that padlock. It says, hey, there's more down in here. Let's get down into the programming menu. So I can set up Totalizer 1 or Totalizer 2. Let's set up Totalizer 1. So what it's trying to ask me here is, okay, for Totalizer 1, where would you like the decimal place? By unlocking my padlock and changing the particular value to find the decimal location that I would like, I use the circular pattern of keys and can change the decimal place to where I want it. Where would this come in useful? Well, let's say I had a particularly high flow rate and I chose to totalize not in gallons, but in K gallons. Every digit registered is 1,000 gallons. But I don't want to wait 3 minutes to see something pop up on my totalizer for an effective change. I could go ahead and give myself 100 gallons. With engineering units of K gallons, that would be 1 decimal place. So every 100 gallons, you will see a 10th register. We'll leave it as straight digits. Now, if I use my digit key, the lower center key, I scroll across and pick the engineering units for my totalizer as well. US million gallons, cubic meters, liters, and let's continue along until we get US gallons and enter. Now, strolling across, there's additional questions. Hey, is totalizer number 1 going to be forward? And here's your choices: forward, reverse, or net. We'll leave ours set for forward, and let's continue on. Well, there's only really 2 fields to that: setting my totalizer in engineering units, and whether I want it forward, reverse, or net. Let's go back up. Don't forget that the upper left-hand key lets you get down into programming and back up out. So let's come up to the main totalizer entry. And instead of Totalizer 1, I can come over and make those same changes to Totalizer 2. Totalizer 2 could also be configured. Coming back up to the main menu of Totalizer, scrolling across, we have low flow cutoff. Low flow cutoff is a value that's related to your Q factor, and it's set as a percentage. So if you set your Q factor for 0 to 100 GPM, so 20 milliamps will be represented by 100 GPM, and I set my low flow cutoff at 9.9%. That means that any flow below 9.9% of 100 GPM, which is my Q factor, the meter would recognize as irrelevant flow and would shut off and display 0. If I want to change that value, it certainly can be changed, one digit at a time. Default is 1.5%. You can see if you change your Q factor, the value at which I'm going to show 0 GPM will change as well. So two factors are interrelated. Scrolling across from low flow cutoff, I also have empty pipe detection. Empty pipe detection can affect the relay output. So if you had an empty pipe and you activated empty pipe detection, this could give you a flag saying, hey, there's an error here. A magmeter does depend upon having a full pipe. So having a flag as an error and tying it to a relay can be helpful in some applications. Getting back up to the main menu under Basic Settings, scrolling across to Meter Output, you'll see I have Current Output. I also have, under the outputs, Digital Output and Relay Output. Coming back to Current Output, I mentioned that right now the default value is off. If I go ahead and change that value, unlock it with the padlock key, and change that to on, you see my fault symbol. There's that block with a diagonal line flashing at me. If I go ahead and change that back to off, my error symbol goes away. So it's important to note, a lot of people will use the 4 to 20 milliamp output. But if I don't have continuity in the loop, you will get an error, and it will advise you to look at your wiring. Current output, let's scroll across to digital output. Digital output allows you to generate a 24-volt pulse of a given duration, of a programmable duration, if you will. So I can give you a 24-volt pulse every 1,000 gallons or every 100 gallons, and this is all programmable. The on time of that pulse is also programmable. For those applications where I'm feeding that digital pulse into a PLC, 25 or 50 milliseconds would be fine. But if I'm trying to saturate the coil of a relay, that might take 50 milliseconds or 100 milliseconds. If I'm not using the digital output, I'm going to go ahead and turn it off. And you'll see that I can have a pulse, a frequency, or error levels for my digital output. Or I can assign it to direction or limit or batch. I'm going to go ahead and turn it off. Also, I have a relay output. If I'm not going to use the relay output, which most applications do not, I go ahead and leave it off, but I can assign it to error levels, error number, direction or limit. Remember, a magmeter can differentiate flow. It can also activate an optional cleaning, pipe cleaning, for either greasy buildups or for scale type buildups. We're going to go ahead and leave it off for now. Scrolling across from outputs, we have an external input. Very few applications use external input, but a contact closure coming in could freeze the output at the last measured value, go high, go low, or to a predefined limit. Sensor characteristics. Under sensor characteristics, I can interrogate the sensor prom that's shipped with that particular unit, that particular body. Remember, all the bodies are not just built and shipped to you, they're built and put on a wet stand with all kinds of test run to calculate offsets so that we can deliver the accuracy stated for the particular type and size of meter. I want to make sure that that sensor prom is present. So under sensor characteristics, I enter, and I should see sensor prom installed. If I don't see sensor prom installed, it's not going to work right, and it will think it's a 2-inch meter. Scrolling across from sensor characteristics, I have reset mode. And under reset mode, if I opt not to include in my operator menu the reset of Totalizer 1 and or Totalizer 2, I have to come in, know my password is 1000, and come to the reset mode to reset my totalizers, both 1 and 2. If you're only using one totalizer, it would only affect one, would only be important for one totalizer. I scroll up to the top to the reset mode. Service mode will allow you to force your 4 to 20 milliamp and do a number of diagnostics, but usually not needed during the basic setup of the meter. As you see, I screwed up and got out of the configuration menu. Scrolling across once again, the reset mode, service mode. Operator menu is the other significant entry. Remember, there's two basic modes, operator menu and configuration menu. Under the operator menu, you determine out of 20 potential screens which one you want the operator to have access to. There's a lot of information such as runtime, etc., that you could display, size of meter, number of different variables, but why make it more confusing than it needs to be? On my operator menu, I come down, and my upper line right now I can assign to flow rate. If I wanted to assign it to Totalizer, I could. Totalizer 1 or 2, I'll leave it for flow rate. The second line of my display is my text line, and right now it's set to show Totalizer 1. Now, I can also have one of those operator menu screens to show Totalizer 2. Most applications only require one Totalizer. So as I'm coming through the available screens for operator menu, those that have a check mark are included in the menu. If I choose to delete them, I open up my padlock and change that to a division symbol. That means those entries are not included. Scrolling across, I could show you Qmax. Remember, that's the value to represent 4 to 20 milliamps. Text is flow rate. No, mine's set for Totalizer. I could show your flow rate in percentage. All these entries with a division symbol are available, but I have chosen not to include them in my operator menu. Now here's a very important one, is resetting your Totalizer. Do I want to allow my operator without the password to go and reset my Totalizer? Maybe you do, maybe you don't. Most folks do not. And so I want to change that check mark to a division symbol and re-enter it. The same holds true for reset Totalizer number 2. There's text sensor size, sensor type. The last entry on here, errors pending, is one that I suggest to all customers to leave into their operator menu. That allows you to see right from your operator menu any error. So when I see that diver symbol or that square box with a diagonal line flashing, my operator has the capability of scrolling through to see what that errors represent, whether I have a burned out coil, an open on my 4 to 20, etc. Returning back to the operator menu now, you can see the changes that we have effected. Scrolling across, I've just left you 2 screens. Rate of flow and Totalizer 1, with the digits representing how many gallons have passed. The second screen is my error screen. Once again, there's more advanced features that you could program into a setup, but this will give you enough to get up and running. If you have any questions, please contact your local Gilson office at 1-800-860-4499. Thank you.